Hello everyone, this is a video walkthrough for homework 6. So in this homework, you have 5 problems. I'm going to give you some idea how to do each problem in this homework. So let's start with problem 1. And before we get started, I just want to give you a brief idea of homework 6. So the homework 6, the focus is on Markov Chains, right? So including the matrix P, which is the matrix of transition probabilities. You have regular matrix, and you have a steady state matrix, right? We're going to go through all of that together in these 5 problems. So let's start with problem 1. So the setup for the screen is that I have my node on one side and I have the questions on the other side. These calculations, I'm going to use Python to help with the calculation, so we can avoid doing this by hand if the problem gets a little bit too complicated. All right, so problem 1, the consumers in Shelbyville have a choice of one of 2 fast food restaurants, right? The Rusty's and the McDonald's. Both have trouble keeping customer. Of those who last went to Krusty's, 61% will go to the McDonald's next time. And of those who last went to McDonald's, 82% will go to Krusty next time. So this, again, the Markov chain model, right? So we just have 2 different states or 2 different restaurants in this case, Krusty restaurants and McDonald's restaurants. Okay, so let me start here. So homework 6. Let's start with problem 1. So you have 2 states. Right, one is for, let me use this, Krusty, and the second one is McDonald. So it say that of those who last went to Krusty, 61% will go to the McDonald next time. So you have the arrow pointing from Krusty to McDonald. Right, so you have this is 61%. So that means there is 38% of people who went to Krusty will go back to Krusty next time. So you have this is 38%. Okay. Now, of those who went to McDonald's, there's 82% will go to Krusty next time. Let me use a different color here. So 82% going from McDonald's to Krusty next time. But of course, there's still 18% of people who went to McDonald's will go back to McDonald's next time. So this is basically the setup. Right. So you are given the information. Now you transfer the information into the schematic. Right? Now, part A will tell you or will ask you to find transition matrix or matrix of transition probability describing this situation. So now with this schematic, you can transfer the information into the P matrix, right? This is a 2x2 matrix because you just have 2 different states, the Krusty state and the McDonald's states. Okay. So let's start with part A here, and the matrix P is a 2x2 matrix. Right. So you start Krusty, you go back to Krusty. They are 38% or 0.38. Of those who went to Krusty will go to McDonald's next time. There is 61% or 0.61. So we're done with the Krusty state or state 1. Now we move on to state 2. Right? Of those who went to McDonald's the first time, there's 82% that will go to Krusty the next time. So that is 0.82. And there is only 18% of the customer will go back to McDonald's. So is 0.18. So let's enter this information into our solutions page. So 0.38, 0.82, 0.61, and 0.18. Let's see what we got here. So check answer. So the issues here, I suppose. So I have the wrong calculations here. So this is 39, sorry, instead of 38. So this is 39. Let's check the answer one more time. So this is correct. Sorry about that. So that's part A, right? You set up the matrix of transition probability. So now we're going to move on to part B. So part B say that a customer goes out for fast food every Sunday and just went to Krusty's. Right? So part B, the initial matrix should be 1, 0, because if the customer go to Krusty, there's of course 100% chance that the person will go to Krusty and 0% chance the person go to McDonald's. But the question is now is that what is the probability that 2 Sundays from now she will go to McDonald's? Right? So the setup is going to be that you can do x1, that right for x0 considered to be this Sunday, and x1 to be the next Sunday, and x2 going to be the following Sunday, right, or the Sunday after next. That means you want to find x2, right? So x1 is equal to p times x0, right? You can do the calculations like this, right? So P is equal to 0.39 and 0.82, 0.61, 0.18 times the initial matrix, right? And if you do the calculations correctly, you're supposed to get 0.39 and 0.61. Okay, so that's for the next Sunday. But the question is, what is the probability that 2 Sundays from now, she will go to McDonald's? So that means you need to calculate x2, right? So for x2, you need the information of x1, right, with the same matrix of transition probability. So here you get 0.39, 0.82, 0.61, 0.18, multiply with x1 as to be 0.39 and 0.61. Okay, so this is a matrix multiplication, right? So you're going to perform some matrix calculations. So let me work out the calculation for this problem. So for matrix multiplication, you take the first row here and you combine with the column. You should get 0.39 times 0.39 plus 0.82 times 0.61, right? So that's for the first entry. Now for the second entry, what you do is you take the second row, combine with the column, and you get 0.61 times 0.39 plus 0.18 times 0.61. Right? So that's the second entry. And now if you do the calculations correctly, so the first entry should be 0.6523, and the second entry should be equal to 0.3477. And make sure these two numbers, when you add them up together, is equal to 1. Right? So you write down the answer here in the matrix form. So 0.6523, and this is 0.3477. All right. So the probability that 2 Sundays from now she will go to McDonald's is 0.3477. Right. Because we identified that the first stay is the stay of Krusty customer, and the second stay is McDonald's customer. So this should be equal to 0.3477. Check your answer, and that is correct. Now, what is the probability that 3 Sundays from now she will go to McDonald's? Right? So that means you need another calculations for the x state. Right? So x3 in this case. So x3 is equal to p times x2, for p is equal to 0.39, 0.82, 0.61, 0.18 times x2, which is 0.6523, 0.3477. This is equal to, and this is what you get. The first one is 0.539511. The second one is 0.460489. And this is still for McDonald's, so the probability that you get is 0.460489. Check your answer and see what we get. Okay, good. Now I'm gonna move on to part C and part D. In part C, suppose a customer has just moved to Shelbyville, and there is a 42% that he will go to Krusty for his first fast food outing. What is the probability that his third fast food experience will be at Krusty's? So the initial matrix is going to be different, right? Because now that the initial matrix is no longer 1, 0, but instead it's going to be 0.42 and 0.58. Okay, so I'm gonna move on to C. Right. So the initial state matrix x0 is equal to 0.42, 0.58. Now, what is the probability that his third fast food experience will be at Krusty's? Right? So what you do is you perform the same calculations, but now with the different initial state matrix. Right? So the first outing should give them x0. Now the next outing, you have p times x0. But remember, x0 in this case is going to be 0.42 and 0.58. P is the matrix of transition probability, and it's going to be the same as before, 0.39, 0.82, 0.61, 0.18, multiply with 0.42, 0.58, right? And then you're going to get x1. Now with x1, you're going to calculate x2. With x2, you can calculate x3, right? So x2 is equal to p x1, right? And x3 is equal to p x2. Right. So very similar calculations like before in part B. Right. So I'm going to leave this to you for your practice.
So in addition to the approach that we have to calculate x3, can actually use formula that we show in class, which is the end state matrix. That is, given the initial matrix and the matrix of transitions probability P, you can directly calculate any end state matrix. So the formula is going to be x sub n equal to P raised to the power n times the initial state matrix x sub 0. So in this case, P is equal to 0.39, 0.82, 0.61, 0.18, and x0 is equal to 1, 0. And you want to calculate x3, so therefore you have P raised to the third power times x0. That is the matrix 0.39, 0.82, 0.61, 0.18 raised to the power 3, then multiply with the matrix 1, 0. You can do this by hand by using matrix multiplications. However, I show you a small code. There's a code that we can directly apply to help us with the calculations, and you don't have to perform the calculations by hand. So here's the code that I show in class. So you need some numerical calculations. So import numpy as np, and you need the matrix power, and to take the matrix and raise to the certain power. And this is done through linear algebra package in Python. Is the matrix of transition probability that we have in this case, which is a 2x2 matrix, and you need the x0 matrix, which is the initial matrix. In this case is the 1, 0 matrix. So you do np.array, and then you set up the matrix. So there are just 2 rows in 1 column, so 1, and then go to the next row, 0. So you want to do the matrix multiplications between P raised to the third power times x0. So to get x3, what we can do is we do np dot, which is stand for the dot product, or the matrix multiplications here between P raised to the third power and x sub 0. So the first entry should be the matrix power, which is P raised to the third power. So I do matrix underscore power, and I have P comma 3. This state that I want to raise matrix P to the third power, and whatever result I get, I'm going to perform matrix multiplications, and I want to do this using x0. And I want to print out the result for x3. So we get the error here because I forgot to change the entry of the matrix of transition probability. So for my problem, I have 0.39, 0.82, and then I just have the 2x2 matrix. So here in the second row, I have 0.61, 0.18. So that should work for us. So this is the results that you're going to get when you calculate x sub 3. Again, there's 2 ways to approach this problem. The first one is that in order to calculate x3, you can calculate x2. To get the value of x2, you need to calculate x1, and x1 depends on the matrix multiplication between P and x0. There's another way that you can do is that you can calculate x3 directly using the matrix power, or raise the matrix of transition probability to the third power, and then the resulting matrix get multiplied with x0. And when we do matrix power, we're just going to use the code here. That's helped us tremendously in doing the calculations.
Now we're going to move on to the last part, which is find the steady state vector, or the steady state matrix. And remember, in class we covered this, and we say that to find the steady state matrix of the form x1, x2, right, because you just have 2 different states here in this problem. You need to solve for the equation p times x bar equal to x bar. So we need to solve p x bar equal to x bar, given that p is equal to 0.39, 0.82, 0.61, 0.18, right, times x1, x2 equal to x1, x2. So this is, in a way, is the matrix vector form. What you're going to do is that you're going to solve for x1 and x2. To get x1 and x2, what you need to do now is to rewrite this matrix vector form into a form of system of linear equations. So that is, you take the first row, combine with the column, and set that equal to x1, then you have the first equation. For the second equation, you take the second row, combine with the column, and set that equal to x2. So the first equation gives you 0.39 x1 plus 0.82 x2 equal to x1. And the second equation is 0.61 x1 plus 0.18 x2 equal to x2. The next step is to combine like terms. So in the first equation, you move x1 to the left-hand side and x2 to the left-hand side for the second equations. Now you get 0.39 x1 minus x1 plus 0.82 x2 equal to 0, and 0.61 x1 plus 0.18 x2 minus x2 gives 0. Now you simplify the left-hand side of each equation, so you combine these two terms together, and you combine these two terms together. You should get negative 0.61 x1 plus 0.82 x2 equal to 0, right? And 0.61 x1 minus 0.82 x2 equal to 0. Okay. Now, at this point, if you notice something between these two equations, they are exactly the same, right? If you multiply both sides of the first equation by negative sign, you get the second equation, and vice versa. If you multiply the second equation by a negative 1, then you obtain the first equations. So that means you have these two lines, right? Or the two equations are exactly the same, or the two lines on top of one another. So you only need to solve for, you only need to take care of one of the two equations, right? Or basically you do negative 61 x1 plus 0.82 x2 equal to 0, right? So from here you can solve x1 in terms of x2. And you get that negative 0.61 x1 equal to negative 0.82 x2. And if you divide both sides for negative 0.61, what you're going to get is 0.82 over 0.61 x2, or this is going to be equal to 1.34426 x2. So x1 is equal to 1.34426 x2, right? So I just use 5 decimal places. You can use a little bit less than that. You can use a little bit more than that. There's no exact science here. For some reason, they didn't require the exact number of decimal places that we want to use. So I'm just going to be safe and use 5 decimal places. Okay, but we need one more conditions here, that because we are dealing with probabilities, right? So the value of x1 plus the value of x2 has to be equal to 1. Right? In addition, we have that x1 plus x2 is equal to 1. Now you substitute x1 by 1.34426 x2. 1.34426 x2 plus x2 equal to 1. Well, you get 2.34426 x2 equal to 1. Or x2 is going to be equal to 0.42657. Right? So 5 decimal places. Okay. Now you get x2, you're going to calculate x1. Either you can substitute to these equations, or you substitute back to this and get the value of x1. Right? So x1, then you have that x1 is equal to 1 minus x2, or 1 minus 0.42657, or this is equal to 0.5373 43. Okay, so now I'm going to enter the answer here. So x1 is equal to 0.57343, and x2 is equal to 0.42657. Let me check the answer. So this is correct. Right? Well, we have this incorrect because we didn't enter the answer for part C. That's for you to do the practice. Okay, so we're done with problem 1. Right. So it's a little bit lengthy and a lot of calculations involve a lot of decimal points, numbers. But I want to assure you that when we get to the test or quiz for that matter, I will give you some problem that you can calculate by hand very easily. Okay, now let's move on to problem 2. So for problem 2, they want you to find the steady state vector or matrix x3 of the given stochastic matrix. Stochastic matrix again is the matrix of transition probability with the initial state vector x0. All right. So to calculate x3, you need to x1, and then you need x2, and then you can use the information of x2 to calculate x3. Very similar to what we did in problem 1. So I'm going to move on to problem 3. But again, the setup is very similar to problem 1. Right? So to get x3, you need x2. To get x2, you need x1. To get x1, you do a times x0. And to get x2, you get a times x1. And to get x3, you can do a times x2. Okay. Now let me move on to problem 3. So problem 3 is testing you on the knowledge of or the concept of stochastic matrix. Right? Remember, 2 characteristics for a stochastic matrix or the matrix of transition probability is that all the entries should be between 0 and 1, and the sum of all the entry in each column has to be equal to 1. So that means this missing number added with 0.38, added with 0.41 has to be equal to 1. So that will give you the idea how to calculate the missing value here. Right, so for problem 3, what you have is the missing value, let's call that x, plus 0.38 plus 0.41 equal to 1. Now from here, you can solve for x. Right? Similarly, you get the second column, 0.81, plus a missing value, plus 0.07 has to be equal to 1 as well. And for the last column, you have 0.06 plus 0.23 plus the missing value equal to 1. Right? I hope you can do the calculation from here. Now for problem 4, so the question is determine if the given stochastic matrix is regular. If it's regular, input the smallest exponent, which shows the matrix to be regular, otherwise input 0. All right, so what you do to get the regular matrix is that you perform a series of calculations for the power of the matrix A. Right? So A to the first power, A to the second power, so on and so forth, until you find that the matrix will no longer have a 0 entry. Right? So A to the first power not going to be still have the 0. Right? So this is not the regular matrix. That means you move on to A square. Right? You do the calculations. If you still have 0 in one of the entries, you move on to A cube, A to the fourth, A to the fifth power, so on and so forth. It turned out that this is the upper triangular matrix. Right? So this concept we learned a few weeks ago already. And when you do the calculation for this type of matrix, you raise to the second power, the third power, the 0 still be there. Right? So therefore, this is the matrix A is not a regular matrix. Right? Because it's not a regular matrix, you input 0. Right? So that gives you the correct answer. Of course, your problem may be different from my problem, so be careful to check the calculations. Right? So do the calculation for A to the first power, right? Which is the same with the given matrix. If you have 0 entry in there, it's not a regular matrix. Then you have to move on to A square. Right? If you still have 0 in one of the entries, it's not a regular matrix. You move on to the third power, so on and so forth. Okay, now let's do problem 5. So problem 5 is very, very similar to problem 1. Right? So let me set this up. Problem 5. In an office complex of 1170 employees, right? So the total number of employees is 1170. On any given day, some are at work and the rest are absent. Right? It is known that if an employee is at work today, there is a 78% chance that she will be at work tomorrow. Right? So there's 2 states, right? The stay at work and another stay is absent. Right? So here the stay work, have another stay here is absent. Right? So there is a 78% chance that she will be at work tomorrow, given that the employee is at work today. So 78%. Right? And if the employee is absent today, there is 59% chance that she will be absent tomorrow. So 59% chance that happening. So if one person is at work, the probability of that person missing or absent the next day is going to be equal to 22%. And if the person is absent from work today, there is a 41% chance that he will be at work tomorrow. Okay, so that's give you the information about the problem, and you transfer the information to this schematic, and now you transfer the schematic into a matrix of transition of probability. So the matrix P is, so the first state is at work and the second state is absent. Right? So the person at work will remain at work. The next day is 78% or 0.78. If he or she at work, he or she will be absent tomorrow. The probability is 0.22. The next one is absent, and then one day, then go back to work. The next day is 41% or 0.41. And if the person is absent today, the person will be, the chance that the person will be absent tomorrow is 59% or 0.59. So that's the setup. So let's enter the matrix here. So 0.78, 0.41, 0.22, 0.59. Check the answer. Okay, so that's good. Now you want to make a prediction for the number that will be at work 5 days from now. All right, so that means you need to calculate x5, right? So to get x5, you need x4. To get x4, you need to calculate x3. To get x3, you need to calculate x2. And to get x2, you need to calculate x1. And to calculate x1, you need the information of the initial state matrix, right? Now, how could you get the initial state matrix? So the problem gives you this information, right? So suppose that today there are 936 employees at work. So initial state matrix x0 is equal to, right, so 936 divided by 1170, it will give you 80% of 0.8. The portion of people who are absent from work today is 20% or 0.2. Okay, now with x0, you can calculate x1, that is x1 equal to p times x0. And then you get the information of x1, you calculate x2 equal to p times x1. x3 is equal to p times x2. x4 is equal to p times x3. And x5 is equal to p times x4. And I'm going to leave you to do the calculations as practice. And when you do the calculations, you recognize that you will have the probability for x in x5, right? So 2 entries. The first entry is for people at work, and the second entry is the portion of people who will be absent absent in 5 days, right? But you want to know the number that will be at work 5 days from now. Okay, and whatever portion you have for work, you multiply with 1170 and you get the number of employees will be at work in 5 days. Right. Now, when you do the calculation, you may recognize that the number of employees may not be the whole number. Right? So route to the next number. So for example, in my case, I have that the value of the employees, right, the number of employees is going to be 762.639. So that's not the whole number. So I'm going to round it up to 763. Okay, so on and so forth.
So similar to the first problem, in this problem, you can use the code to help with the calculations. In this case, you want to calculate x5. You can actually do the calculations starting at x1 using the equation p times x0. With x1, you can calculate x2. With x2, you can calculate x3. With x3, you can calculate x4. And with x4, you can calculate x5. However, you can calculate x5 directly using the end state matrix formula. So that is to get x5. You can do np dot, which is again, this is the matrix multiplications, and matrix power. In this case is matrix P, which is the matrix of transition probability. We're going to change the entries in a minute. Here you want to raise to the 5th power, then the resulting matrix, when you perform the matrix power, get multiplied with x0, which is the initial state matrix. In this case, the initial state matrix is 0.8 and 0.2. And the matrix of transition probability in this case is 0.78, 0.41, 0.22, and 0.59. Now instead of print out x3, you do x5, print out x5, and you hit run and see what you got. Again, this is the results that you got. If you want, you can double check with the calculations starting from x1 to x2 to x3, x4, and x5 with this approach and see if the two results match with one another.
So now we move on to the last part of the problem to find the steady state vector or the steady state matrix, right? And again, to find steady state matrix, you need to set up the matrix of the form x1, x2. And to find x1, x2, you need to solve. So to find x1 and x2, we need to solve for we need to solve the equation p times x bar equal to x bar, given that p is equal to 0.78, 0.41, 0.22, 0.59 times x1, x2 equal to x1, x2. Right? So again, the setup is very similar to the one in problem 1. Right? So again, I'm going to give this to you as practice. We also have a similar problem in the example in class. Right? So you can also go back and review that material to find x1 and x2.